All right, welcome everybody to week 17, day 2. Got 1 week left in the semester, then finals week. All right, so I've created a Google form here. I'll post it on the chat channel. Please pick the category that you picked earlier. I don't want to have to go through and find out if somebody switched without asking. The groups looked reasonably good on the chat channel before. Need permissions. Need permissions. Need permissions. You have permissions? There's no option for that. Let's see, settings. Aha, there we go. Okay. Try now. They're not group assignments, kind of. I'm going to allow some sort of cooperation though between you. Okay, so we got 7 responses so far, 10 responses. Good. Raspberry Pi, Bridges, Data Science, Chess, Opencv. Yeah, keep them coming, keep them coming. Good, wonderful morning, everyone. Yeah. This is normally when I would start playing music for you guys, but then YouTube would do a copyright strike. Jeopardy theme music. Sorry, your video's been demonetized. It's not like I make money anyway off of it, but I don't want other people getting paid. Yeah. You don't listen to any new albums recently? They're any good? Next Friday would be easier. Battle at Garden's Gate. Okay. Nurture Potter Robinson. Potter Robinson. Nice. All right. 20 responses. Looks like Chess has just Chamois. Is that the only person who signed up for Chess? I thought somebody else did Chess as well. Alan's Chess. I thought Chamois did Chess as well. Chamois not here. There we go. There. Okay. So, all right, this looks like a good breakdown. So let's talk about the final project. So you guys at this point in the semester have actually kind of learned everything in the class. Looking at my lecture notes, I've kind of gone over everything. We haven't really done anything with classes, but I'm kind of fine with that. You are going to have one final homework assignment, so let's go over that first. One final assembly programming assignment, and it'll teach you more about how call works, compiler, assembler, linker, loader, and then you got your final project, which will be due at the end of the semester, and that's it. So. Can we talk about how to set up the Raspberry Pis? Sure. What do you need to know about setting up the Raspberry Pis? Gpio, like, so what you do is you have your Pi, and you plug it in somewhere. There it is. There's a Pi 3, so it has a micro USB. Yours might have USB-C if you have a Pi 4. And the HDMI, which might be a micro HDMI on a Pi 4, plugs into your monitor. Keyboard and mouse go into the USB ports. Ethernet goes in here, or you can use Wi-Fi if you don't have a Pi 2. Pi 2s don't have Wi-Fi built in by default, but they should come with a Wi-Fi dongle that will allow them to talk to the interwebs. Yeah. And then, will we have an exam like quiz for final? Oh yeah, there'll be a final. There's a final. It's 10% of your grade. It's basically the same as before. Some porch thieves stole your breadboards. Oh my gosh, dude, that's... Imagine how disappointed they're going to be, you know, like, unless they're maker thieves. Breadboards. That's terrible. Yeah, once people broke in my car and stole my school backpack. Had all my Mandarin notes in it from, 2 semesters of Mandarins. I lost all of my Mandarin notes, and it had some custom artwork that my wife had commissioned for me, which was pretty amazing. She hired a artist at Comic-Con. It's a terrible feeling. We know the hardware side of the pie. Shame and I are having trouble with the software side. Get an error not using an RPI. But I'm not using an RPI when trying to run Gpio control. You are not using an RPI when trying to run Gpio control. What do you mean by Gpio control? There's a few different things. There is, you might have to enable something in like Raspberry config. So let's see here. Raspberry Pi over here. There's Raspberry. So you can see, you can get the status of all the different pins on the GPIO. You can set a pin to be high, you set a pin to be low. These are pull-up registers, these are pull-down registers, which means if they're disconnected, they default to low voltage. These default to high voltage. Set a pin as input pin, output pin. Yeah. Yeah. So see if that works. Type sudo raspi gpio get and just see if that works. Gpio-v supports user level GPIO access. You don't have to have sudo. Raspberry Pi supports user level GPIO access. Command not found. What package is it part of? So let me show you how I figure out which package things are in. There's a command called apt that is used for. Let's actually go through that. That's actually a good place to start. So all of you guys should have sudo access, right? So if you say like sudo echo hi, like make sure that works. Yeah. Apt cache search, yeah. But first of all, let's just make sure you guys have sudo access, because this will be a very brief talk if you don't have root access on your own machines, because congratulations, y'all are system administrators now. So and if you're trying to run Windows on a Raspberry Pi, none of this will work, right? Like you gotta make sure you're actually running Raspbian, which is GNU/Linux made for the Raspberry Pi. So it should have been like I said, you should have gone the noobs image and flashed it if it didn't work already. You want to use TempleOS. That's funny. So okay, does anybody not have sudo access? I guess that's the first place to start. Just try it. Sudo. Okay, so what does sudo mean? Sudo means run this command as root. Okay, so if I run the id command tells me my user ID. I'm user ID 1001. Congratulations, me. I'm the first user on the system. I'm part of group ID. My default group is group ID 1001, which is my group, the W. Kearney group. I'm members of these groups, the W. Kearney group, the Sudo group, the LP admin, that's printer, and the teacher group, which is for all professors that use my Raspberry Pi, which is currently me. Yeah, currently I am the only teacher installed on here, but I can put other professors on my systems. I do have a TAs list where certain users can be granted partial, privileges on different things. These are the people that are given access to printing. For some reason, I don't know why Walker's on there or Chamois. It's a bit odd. And then this is the group created for your class. Pulse is for audio, which there's no audio hooked up to it, so knock yourself out. Okay. Is physical computing 2 able to be done in Tinkercad? Yes. You can do it in Tinkercad. Seeing is not in the sudoers file. I feel like you did something illegal. Yeah. So, seeing you're going to have to reflash your SD card. So get an SD card reader, reflash it with noobs, put it back in. By default, the default user on Raspberry Pi is just called Pi, I believe, or RPI, Pi. And the first thing I always do is delete the default user. So the first thing I do is I come in here and delete Pi. So how do you delete somebody? Well, first you create a new account, give it sudo access, and then you delete Pi. It's not showing Raspbian. What do you have, Reed? Default user is Pi, password is Raspberry. Do not put a box like this on the interweb. Do not put this on the interwebs. People will try to connect to your server, and they will try username Pi, password Raspberry. Get this user deleted immediately. Okay. So, the add user command. Yeah, actually, this is probably a good place to begin for you guys. Copy, paste. It's a good place to begin. So after you flash your SD card, log in, and create a new user, and give them the yeah, actually this is a good guide right here. Yeah, so give them a sudo password, sudo access, and then I would delete not Bob, I would delete Pi. So and then you should be good to go. If you're using the GUI for it, which I guess you could do, you can set Bob to be automatically logged in if you want. And yeah, so what is sudo? Sudo means you have root access. Okay, so people that are in the sudoers group have the ability to get root access. And the wherever that is, sudo, there we go. There. And there's something called sudo vi sudo, which changes the sudo permissions. Sudo again allows you to run things as root with a maximal access. Okay, so the root user, root's actually an account, but you shouldn't usually log in as root or anything. So this says everybody in the group sudo has access to any command run as root without requiring a password. So you don't have to do that. It may be a little bit more secure for you to not put in the no password option. I just hate having to retype my password all the bloody time. So I have no password turned on my accounts. You don't have to have that there. But you can do things like, say, create a group called TAs, and they have access to the become command or something like that. And so what you can do is grant certain groups of people elevated permissions, but not all permissions. And so the sudoers file, which you edit by doing that. Oops. I wish you didn't have another assignment with finals week coming up and a final project to work on. You got like 2 whole weeks left. Okay. All right. So yeah. So if I run ID, that tells me who I am. Then if I run this as sudo ID, it will say, look, I am root. You've been able to install an OS yet? Yeah. Well, your final project isn't going to require you to do physical computing unless, I guess that's one you picked. So if you run ID as sudo, it shows that I am now ID 0, which is root. The first user, system user is always root. The first non-system user is 1,000, I believe. So 1,000 and up are standard users, and below 1,000 are system users. Wish you had access to your computer and Raspberry Pi. Well, the next programming assignment doesn't require you to have access to your own Raspberry Pi, just mine. Okay. But you're learning system administration stuff, so this is actually useful stuff. Even if you're even if you want to be a programmer and not a system administrator, it's one of those realities that the boundaries blur a lot, and you end up having to maintain your own boxes, and maybe you're not going to be as professional at it as a professional system administrator, but knowing how to do things like what I'm about to show you is pretty important. So, okay, so first step is, once you get here, once you get your sudo access set up, you want to be a professional system administrator, then go for it. Yeah. I'm just saying, I'm not, I mean, technically, I guess I am a professional system administrator because I'm getting paid to do this, but no, I have friends that are system administrators, and they're way better doing this stuff than I am. I Google a lot of stuff, and kind of figure it out, and I use Ubuntu, which is like the easiest, distro to use and things like that. But I've been administering my own Linux boxes for, I don't know, 20 something years now, and it's not too bad. It's not unreasonable. Stallman doesn't even administer his own machine. When we were having lunch, I was like, how do you make sure that your Linux distribution, your GNU plus Linux distribution, doesn't have proprietary software on it? And basically the way they came out was that he just has an MIT student set up his laptop for him. He's like, just offer them extra credit and they'll do it for you. I do it myself. Distro. What is a distro? So there's different distributions of Linux, and some people do distro hopping, where they jump from one distribution of Linux to another, and I basically have just been using Ubuntu. I used to use different ones, and I've tried different ones in the past. I've mostly just switched to using Ubuntu because it's got the best support out there. When you're like, how do I install X for Y? You're going to get more hits for Ubuntu than for the other ones. So there you go. Manjaro, Mint. So Manjaro is it's related to Arch, which is a fairly popular distro. I think is easier to use. And so you could download Manjaro and try it out if you want. There's Ubuntu. MX Linux is a desktop based on Debian. So Debian is the root distribution of Ubuntu. So Ubuntu is kind of a derivative version of Debian. These things get complicated. So yeah, basically I don't think the distribution matters particularly much to me because I don't use desktops on Linux. I am very much a terminal guy. Desktops just slow me down, so I think most of the differences just come down to the package managers for me. And so Arch has its own package manager, and packages are how you download and install software and things like that. Ubuntu's got Flatpaks now and some other stuff. So Yeah, so I just use Ubuntu because, like I said, I'm not a professional system administrator. I just pretend to be one, and it's just easy to find documentation and support for it. When I used other distros, it was like, like, all right, I'm having this issue. My quotas aren't working. What the hell, Has anyone else seen this problem on this? And it's just better to get support, in my opinion, or at least for me. It is. Okay, so sudo apt. There's apt-get and there's apt. Should I explain the differences? I don't know, maybe. So apt and apt-get are basically the same tool. You can apt-get has it's considered more low level. If I did the same thing, sudo apt update. See how it's got colors? It's got colors. Look, and yeah, that's yeah. Yeah, the output's slightly different. If you want to see which things can be upgraded, you do this, and it'll tell you all the different packages that are ready to be updated if you want. And it's in color. That's the main difference. Apt-get is more suitable for scripting. Apparently, I've used apt like you can see the difference. Like it doesn't. It's not like apt-get is like, you have to have a cybernetic implant to use it. Like they're literally like 90% the same. But they recommend using apt instead of apt-get these days. I don't know. Okay. So was it apt cache search them? So if you want to see you're a distro hopper, yeah, it makes sense. I've switched distros like 4 times since quarantine. Makes sense. Yeah. I don't know. It's like I used to, and then I just kind of got tired of it. Like I said, especially if you don't use a desktop, like it's like, like I don't really see much, benefit to it. The main issues that concern me, actually, which are probably different from most normal users, is I want to have the latest compilers, right? Because especially like when I started teaching here in 2015, the compilers didn't even default to C++ 11 by default. They defaulted to C++ like 98. And so having the latest compilers meant having support for and default versions of modern C++, which made a pretty huge difference. And when you use Ubuntu with a stable release, they tend to not upgrade the compiler versions in order to keep everything stable. And so you have to download, well, you have to set up a repository to get the later packages and things like that. It's kind of annoying. So, okay, so let's say you want to search for a program to install. Like, let's say you want to search for a NetHack, which sounds like a hacking tool, right? So there's a command called apt cache search, and so you can search for every package that has the word NetHack in it, right? And so this shows you the different things, and you're like, oh, /m GTK window port, GTK window port, STL window port, X11 window port. Guess what? I don't have no fancy window thing here. So let's say I just want to install /m, right? So what I can do is say sudo apt install /m. Okay, this command here is how you install new software in Ubuntu. There's Pacman and other package managers for other distros, but for Raspbian it's just aptitude is what it stands for. So sudo gives you root access, apt is the name of the package manager, install is the command, and /m is the name of the package that is to be installed. And so when I run it, it says the following additional packages will be installed, /m common. It suggests you might want to install the X11, STL, or GTK versions. No, I don't. I don't have any of the, I mean, technically I do. I mean, it is, I guess, running LDXE right now. It's not hooked up to anything. It's just hooked up to an Ethernet card, or Ethernet cable. So I don't care about those. It tells me it's going to consume 6 whole megabytes of hard drive space. Do you wish to continue? That's 6 megabytes. That's a lot of hard. Okay, yeah, hit return. And then you can see we got colors because I used apt instead of apt-get. right? Look at how fancy it is. Honestly, there's no significant difference to me. All right. Is Kearney's mic popping for anyone else? WSL is just a subsystem. Your speakers are dead. Got any results for Raspberry Gpio? So let's search for that. So let's search for Gpio, and you can see that there's one called Raspberry Gpio. So you do sudo apt install Raspberry Gpio, and I already have it because I was running it earlier, right? And it says Raspberry Gpio is already the newest version. Go away. But you can see all the different packages that are related to the Gpio thing here. And wiring pi is probably a pretty important one. So if you don't have that, you're going to want to install that. Wiring pi, sudo apt install wiring pi. I already have the latest version, but if you don't, you'll definitely want to have that. So let me make a list of things you should install. Okay, actually, first thing. Okay, here. Let's actually just write these down. So you want to be a system administrator. 621. To make a new user, grant sudo access to it, and delete the Pi account. And there. Dive into my font. Step 3, make a new user. Okay. Sudo apt get update, and sudo apt get upgrade, and sudo apt get dist upgrade. So this, so in Unix, if you run a command with a double add after it, it'll run the first command, then it'll run the next command, then it'll run the next command. And so this thing here is going to it'll query the different package servers, and it'll give you a list of what packages are available. This will upgrade any of your existing packages to the latest version, and then this will do the same thing, but it might also upgrade the kernel and like actually really important stuff. So if we did this, sudo apt upgrade, and you use apt-get or apt, it doesn't matter, except dist upgrade is called something different for apt. And so this is now going to upgrade all these different packages that need to be updated. And so you can see it's now hitting the update servers and downloading the updates and things like that. So that's going to take a while. So that's why I typed apt-get here, because I don't remember what the command is for apt. They changed the name of dist upgrade for some reason. The other two are the same. Update and upgrade are the same. So I imagine none of this is necessary for Tinkercad. Yeah, but you should probably learn how to administer a machine. Right? Yeah, Tinkercad is an Arduino, and so that's a different thing entirely. You can flash noobs onto 64 gig card. Yeah, there's two different installations of noobs. One is minuscule. So copy this here. This one is 2 gigs. So I think. And then there's Raspberry Raspi. Fig, am I spelling that right? It's still updating. Raspi. Okay, so this configures your Raspberry Pi, and so if you have trouble, Rasppi config, sudo raspi config, okay. Really? Okay, so system options, let's see. Wireless LAN, audio, password, change the password for your user, set the name of the computer on the network. My name is Chibi, right? Display options, interface options, performance options, localization, advanced, update, let's see, system settings, boot or auto login. So my system is set to automatically boot up as wkerney with it in the text console, because I don't give a rat's ass about desktops. And if I want, I can run the desktop for some reason. If I wanted to. So that's nice. You just boot up without having to log in. It'll just automatically log you in. Network at boot, don't care. Do you want splash screen or text boot? No, I want text. Because text will show you all the things that are happening behind the scenes, whereas I don't want a pretty little picture. Power LED, change the behavior, cannot be changed. Okay, whatever. Okay. Display options, you can choose what resolution is coming out of the Raspberry Pi, which I don't care about because I'm connected over SSH. Connections to peripherals. So you can enable or disable the Raspberry Pi camera, enable or disable SSH. That's actually really important. So go to peripheral options and enable SSH. Make sure no default password. Make sure you did step number 2 and don't have a default password still. And so that'll enable SSH. Performance. Let's see, where are we? Interface options. Okay. VNC, don't care about. SPI. So you sometimes have to enable I2C and SPI in order to allow like your analog to digital converters to work. So turn on I2C and SPI as well. Need them. Don't care about that. Don't care about that. Oh, and then remote GPIO. Would you like the GPIO server to be accessible over the network? Ooh, sure, why not? Okay. So, all right. Performance settings, overclocking, performance, GPU, memory. Don't care. So the behavior of the GPIO fan. Okay, I don't have a GPIO fan. All right, so advanced options, desktop GL driver. Don't care. Don't care. Don't care. Don't care. Don't care. Okay. Okay. So running update and upgrade took an actual hour on your Pi. Yeah, that's normal. Okay. And you can see over here, this thing is still running. It's updating Java, it looks like right now. All right, so the next thing I would install is fail to ban. So apt cache search fail to ban. And so this is a really important thing that you want to have installed. Sudo apt install fail to ban. I'm currently updating right now, but it's installed anyway. So you definitely want that there. Should probably even install that before enabling SSH. Because what happens is that when people discover that there is a Linux box attached to the internet, accessible through SSH through a firewall, they will hammer it with password attacks, right? They'll try guessing the username Pi, password Raspberry, right? They will sit there and guess usernames and passwords over and over and over and over and over and over and over again. So what fail to ban does is it looks for unauthorized accesses, like if somebody tries logging in and failing, then by default, I think it's like 5 wrong passwords within 15 minutes gets them banned for 15 minutes, something like that. So that's just all the things are configurable, but you can whitelist and blacklist things as well. The defaults, though, work pretty well for it. So if you just install fail to ban, it'll out of the box work pretty well, unless you forget your own password, which happens to my students sometimes. They try logging in on the server, they forget their password, they get banned, their IP address gets banned for 15 minutes. Then they're a sad panda, especially when it's right before a deadline. All right. What flashes noob onto SD and turns into oof for me? What's the problem? Yeah, just do the whatever is recommended. Just do that. Trust me. Just do the recommended things. Your SD card is only it's too small. Yeah, if your SD card is too small, then there is a smaller version of it that takes up less hard drive space. Yeah, the Raspberry Pi, people give you a flasher, which works pretty well. I've used Etcher before too. What does fail to ban do? So what fail to ban does is it just monitors your networking logs, and when it sees an IP address have a wrong password guessed 5 times within 15 minutes by default, then it will automatically put that IP address into a blacklist. There's a firewall basically built into every Linux box, and it automatically rejects any connection from them. After 15 minutes, it automatically pulls it out of the blacklist, and then they can connect again. And so what that does is it goes from having people being able to try millions and millions of usernames and passwords and also eat up your network bandwidth to 5 every 15 minutes, which is negligible. So it's a really really useful thing. Ban China and Russians' IP ranges. Yeah. Won't work if they spoof their IP, sure, but they have to have a working IP in order to try connecting to you. So they could VPN hop and things like that, but they still have to have a valid IP address to respond to you. Right? This doesn't stop you from getting SYN flooded. It just stops them. It slows down their ability to guess usernames and passwords. And so you want to make sure you also have a good password, like your password isn't Hunter123 or password with a 3 for the E or something like that. My fill demand won't install, and the command to fix it doesn't work. Are you currently updating, Shemi? If you're currently updating, you can't do it again, right? Like you can only have one update process going at a time. Just let it run for a while. Can your Friday assignment be delayed so you can get a new SD card? Sure, I guess. I guess we can make the next physical computing assignment due next Tuesday. It's not really supposed to be that hard. So, POG, I guess. Yeah, I do actually wish that Radio Shack, and I never thought I'd hear myself saying it, I wish Radio Shack was still around. Because for a long time it was like, why is Radio Shack still around? I don't understand how that place is still in business. But Radio Shack, you could just pop down there and be like, I need a DC motor. And they're like, here you go, it's $1. You know, I need a, you know, wish you had a Micro Center or something. Yeah. Best Buy occasionally has like Raspberry Pis and stuff like that. I don't think they do though. Right now. Green, do you work at Best Buy? Pick up, ready in 1 hour. Yeah, okay. So they do actually have a Raspberry Pi 4, you know, starter kit, ready for pickup in an hour. 2 left at the store. This one I don't think comes with a breadboard, but it comes with noobs installed and stuff like that. So, I mean, it's up to you. Like, I don't want to force you guys to pay $100 or something. $70 for this one. It's not bad. Oh well, $35. Yeah. All of these are not nearby. You can probably Amazon it overnight or something. You guys have RTX in stock, yeah. So yeah, I finally got my 3090 just by signing up on EVGA's waitlist thing. You guys know about that, EVGA. So basically you can queue for right here. You can queue up for a 30 series graphics card. And that's actually how I got my 3090, was by doing this. So you can basically be like, yeah, I want a 3080, and then there is a queue notify system. Yeah, and so you have to join their website, and then once you join the website, you can pick a card that you want, and then when it becomes ready, they send you an email, and when you get the email, you have 8 hours from getting the email to buy the card. Mine was actually slightly longer than 8 hours, and I still went through. So, so I actually got a 3090 below MSRP. So that was nice. How long is the wait? By the time you get it, you have a 4080 out. Yeah, it took me 6 months. I signed up for it like half a year ago, and it finally popped. So yeah, just go to EVGA's website. I like the system. Like, it's a lot better than this sort of randomly like, oh, there's a drop at Newegg, and everybody goes on there and checks. And yeah, so having that system works to defeat the scalpers and cryptocurrency people. So unless I guess you create a ton of accounts all at once or something. I don't know. Okay. We haven't had a graphics card ever in store for the 30 series. Okay, so once you do that, you should be pretty much good to go. Step 6. Try Gpio. Yeah, we need to install sudo apt install wiring pi, step 7, sudo apt install. Raspberry Gpio is the name. And yeah, I know there's others. I just can't think of them off the top of my head. Gpio utils maybe. Okay. Download the SunFounder source code. And if this seems like a lot of steps, yeah, welcome to the world of being a system administrator. Like setting up a new box is like, it's a thing. Every 2 years, I wipe the official CSI4X server, reformat the whole thing. So I have to back up all the user files, back up all my shell scripts, and then reformat it, put on the latest and greatest version of Ubuntu, move everything back over, set all the permissions back up and things like that. And it's an annoying kind of process. There's better ways of doing it. Like supposedly Ubuntu has an update system that will update you from 1604 to 1804 or from 1804 to 2004. And it's broken every time. So before in the past, from like 10 to 12 and 12 to 14, it worked fine. But going from version 14 to 16 broke, 16 to 18 broke, and 18 to 20 broke. So it basically works out to just being a full reformat and reinstall each time. And so I've gone through these steps, many times. Every 2 years I go through it. It's like a semi-annual house cleaning kind of thing, right? Every spring you clean your house. Okay. Is there no way to do GPIO stuff with Ubuntu on a Pi? This is Ubuntu on a Pi. This is Ubuntu. It's just Raspbian. Yeah. You didn't install Raspbian. You installed Ubuntu. You're using Ubuntu. I don't know. Put up. What does your apt cache search say? Let me do that. Nothing? Empty? Yeah, you're probably going to have to reformat them. Okay. Or you can download the source code for it and run it from... you can probably rebuild these things from source, which is a pain in the ass. Hazelton says you can add repositories. Yeah, so there's... let's see, where is the repository? It's like in the apt... app.list, it's called. Sources.list. Yeah, so you try adding this one. See if that works for you. Get source. So that may open up some additional packages for you. I don't know. Are you on a 32-bit or a 64-bit system, Lee? 64-bit, it won't work though. You can't do anything on 64-bit. The assembly is all different. Well, maybe you could. I don't know. You're not going to be able to do any of the assembly assignments. So, the assembly, if you boot a Raspberry Pi in 64-bit mode, 32-bit assembly doesn't work. That's why I keep using a 32-bit operating system. What error do you get? Depackage. This is what I get when I run fix broken install. Sunfinder source code. Okay, so. Seems like a default, a good default setup thing as well. Yeah, make sure you have Python installed. Wiring Pi. Okay, there we go. So yeah, it'd be nice if you just kept my font size the same. And that, Okay, so if you run this, this will download the whole directory into a folder for you. Yeah, and so, or you can, do you guys know the Wget command? It's actually probably pretty useful. Time to go to Best Buy. See, I'm sending business your way, Mr. Green. Dark mode is here. I know, dude. It's already dark. All right. Sunfinder. Sunfinder sensor kit. Right. So if you ever find like a zip or something like that to download, yeah, sure, you could download it using git clone, and then you can pass this HTTP here, or if you copy the hyperlink, you know, I right clicked on download zip, hit copy the hyperlink. Come over here. I think Ubuntu doesn't actually do automatic updates. I think that's actually a package you have to install. Apt cache search automatic updates. Quake. That's cool. I don't know what that has to do with automatic updates, but yeah, you can set up timed updates, but by default, I think Ubuntu doesn't actually do it. There's a package you install, and then it will do automatic updates, and you can choose to have it do just non-breaking updates, or security updates, or all updates. And what it does, it puts a cron job in. So cron is a tool in Linux that will run things at certain times. So you can have cron tab. Let's see. Cron. So any shell script you put into the cron daily thing gets run daily. Anything you put into cron hourly gets run hourly. There's also a cron tab file that gives you more fine-grained control than that. But basically, if you ever want something to run periodically, then that's your go-to. Okay. So if you want to download a file in Linux, use wget, and the zip file we had a second ago. My clipboard, right click, copy link. So if I want to download this whole zip file, I can just wget, paste the URL for the zip file there, and the wget command will download the entire zip file to the local machine. So probably using git clone is probably the better way of doing it, but I use wget all the time as well. It's an easy way of transferring files over the internet. It's like a web downloader thingy, right? So, you know, somebody puts up a zip file, you just wget it, and then you can run unzip. And again, if it's like unzip not found, then you can apt cache search it, or you can just be like, what is the unzip command for Ubuntu? Right? And there'll probably be some Stack Exchange or Ask Ubuntu. Yeah, Stack is part of Stack Exchange Network, I think. No, that's part of the Ubuntu's website. Well, it's using the Stack Overflow interface. What's the correct way of doing it? You type unzip, and if you don't have it, there you go. And so, if you ever need to find out where a command is and what package it is in, you can usually just Google it real fast. So that's the package that has the unzip command in it. So. And so I just downloaded the latest and greatest of the Sunfounder code, and I don't know, maybe this is different from the old one. That's a good question, actually. So that's how you download things. That's how you unzip things. You use wget to download them, unzip to unzip them. Yeah. Yeah, okay. Like this thing wouldn't still be updating if I had automatic updates enabled on the Raspberry Pi. Yeah, it takes a while. So I think once you got that, then it's just a matter of like you try running something, you're like Vim, and notice I have NeoVim installed here, right? And so like you could be like, okay, let's do sudo apt install NeoVim or something, you know. And so you just whenever you notice you need a program that you don't have, just sudo apt install it, and that'll download the program to your Raspberry Pi. Okay. So that's how you system administer. Okay. So for your physical computing project, which I guess I'm moving to like Tuesday or something, so I don't really care. It'll give you time if you need to like Amazon in another breadboard or something. Basically what you're going to do is make sure once you get here, right, and you can do this, and, you know, no, or the other one worked. Let's see. Yeah, whatever. Once you get there, then you should be able to hook up the sensors, and you know, start off with something simple like a tilt sensor or something like that. Just follow the Sunfounder guide. They show you exactly which wires to hook up, and then you tilt it, and then an LED will turn on, or it'll print something on the screen, and it'll feel good. It's a good feeling. Now, if you guys are using Arduino, the Arduino look is a little bit different. Arduino. I've done a lot less Arduino stuff than Raspberry Pi stuff. A new version of Arduino is available. Do I care? No, I don't care. Okay, so so Arduino programming is designed for like my daughter. You know, like she did the aquarium thing in 2nd grade, and she did the camel thing, which I don't even think required an Arduino. It was just physical switches, stuff like that. So this looks like C, because it is. It's not C++. It's C. Not C++. And the most basic way of programming Arduino is that there's really only a couple things you need to worry about when you're doing Arduino programming. First of all, you can set up some globals, like I got some global variables sitting up here in global space. And POS, which is position. It's not an abbreviation for anything. LED, which is an abbreviation for a light emitting diode. And so you know, I just have these different globals up here that I just changed to mess with the angle of the fish or whatever. So yeah, I just set up some globals, however different things. 801. Where's 801? I don't see it. Okay, and so in Arduino programming, there's really two things you worry about. You got your globals here. It's the name of the file. Oh yeah. Yeah, it's because this is my daughter's aquarium project. So, so on Arduino, there is a function called setup that runs once. So when the thing turns on, it runs setup. That's it. And you typically do this to choose whether a pin is an input pin or an output pin. So in this case, it is setting the LED pin, which is pin 6. That's one of Arduinos have a different numbering system than Raspberry Pis. And I think you guys have already seen how weird the numbering systems are on Raspberry Pis. It's like, why are there 3 different numbering systems? I don't know. Yeah. So, yeah, Arduino's got their own thing. And so pin 6 can be done on Arduino as PWM. And I'm saying set it as an output pin, because you have to tell it whether or not the thing is going to be reading from a pin or writing to a pin. Am I writing voltage or reading voltage? Bad things happen if you do it backwards. And then they have a servo library that handles the servo stuff. Servos are motors that you can set the angle on them. A DC motor just spins, and it can spin faster, it can spin slower. A servo motor, by contrast, you have precise control over the angle on it. And so, in order to make things easy for 2nd graders doing this kind of Arduino programming stuff, they have a servo.h header here, and you can just create a variable called servo myservo, and basically I'm attaching pin 9 to the servo. Okay, so clear. Now that's actually pin 6, isn't it? 6. Move these around a little bit. So the LED pin is pin 6, and the servo pin is pin 9. Did I move these? Yes. Pin 9. Okay. All right. It's bit rot, right? When you change things, bit rot. Question mark, question mark, question mark. What's the matter, Hazelton? What's wrong? Oh my, what's wrong? Something bad happened? I see an oh my, and your comment says pin 6, but servo pin is 9. Yeah. I think I moved the things around. You have to update your comments. You know. All right, it's fixed now. Okay. So basically, this will allow you to control a servo using their servo header file, and then the loop routine runs over and over again. So in Arduino, you've got your global variables, you got your setup, and you got your loop. What does loop do? It runs over and over again. And that's an Arduino. Like, that's how you program an Arduino at the most basic level. You just have your global variables, you got your setup, which runs once, and you got loop, which runs over and over again. Congratulations, you're an Arduino programmer now. You might notice there's no main. That's normal. right? Because you're on Arduino Studio here, and it's a stripped down version of programming. So yeah. So inside of loop, I just keep counting up a counter. Counter starts at 0, I imagine, yeah. And so every time loop runs, counter ticks up by 1. I do that because I'm using that as sort of a surrogate for time. There's probably a better way of doing this, but it worked. It worked fine. And so basically, every time loop gets called, counter goes up by 1, and then I take the time, which is the counter, divided by the period, which is 3. So I basically have these constants here for period and amplitude, which controls the wavelength and amplitude, the frequency and the. So I basically set up the trig for my daughter here, right? So amplitude times the sine, you got the period in there, you got the angle that it defaults to. It defaults to 90 degrees. And so then I give it to my daughter, and she messed with the period and the amplitude until she got the fish having a sine wave motion that looked realistic. So I did the trig, and then I let her set the constants on it. And then the brightness of it is, it should probably be after that. It doesn't really matter. So the brightness starts off at 15, and then the Arduino actually has an analog output. So you can actually do analog outputs on the Arduino, which is really nice. You can say run it at 50% max power or whatever, and the Raspberry Pi can't do that. So it's actually something the Arduino does better. It can actually do analog out. Yeah, do you remember how many analog outs it has, Reed? It's like 4 or something like that. It's been a while since I messed with it. It has a little like tilde on the pin to show you which ones are analog out. And then, so what I do is I have this brightness value. The brightness value goes up by fade amount. So it goes up by 1 every frame. And once it hits maximum brightness, then the fade amount becomes inverted. And so it'll go up and up and up and up and up. Once it hits 70, then it goes down and down and down and down and down. And once it hits the bottom, it goes back up again, and it creates this nice brightening and dimming effect. 5 analogs, yeah. And then it just pauses for 50 milliseconds. So we get, 20 frames a second. So 20 times a second, it will update the servo, it'll update the brightness of the LED, and we're good to go. And so this is this was my daughter's 2nd grade diorama project, right, where it's controlling the angle on a fish. So the fish is moving in a sine wave, and the brightness, and my daughter also set these values as well, controlling the glowing of the underwater LEDs. 6 analog ins, 5 analog outs. Yeah. 6 analog outs. Okay. Yeah, it's nice. I wish Raspberry Pis had that. Honestly, it'd be really nice. So, yeah, this is what Arduinos look like. They're pretty easy, and you can find source code all over the place. They're very well supported as well. So, yeah. Okay, so let's talk about your next programming assignment. So for this assignment, you're going to be making a compiler. This is normally a junior level class. It's actually 2 classes at UC San Diego, or it was. It might have been combined down to just 1. I don't know. Who knows? But compilers is one of the reasons why it's important to know assembly. Because if you're going to work on a compiler, you'd better damn well know assembly, right? And so, some people write their own compilers. Not too many, but it's actually not that unheard of, right? If you have some specific project and it And like it's people have been known to just make their own programming language and make their own compiler for it and interpret the results of it, and like Quake C, for example. John Carmack just wrote his own programming language and wrote his own compiler for it and wrote his own interpreter for it, and there you go. You had a scripting language for a video game. A lot of people optimize the output of compilers, right? So you fire up Godbolt. This is a very common thing, right? Where people are like, what's faster, a linked list or a vector, right? And so they'll do something like this. They'll come into Godbolt, right? And they'll do like include vector, vector of ints, named vec, size 100, compilation failed, there we go. And so you can take a look at that, and cannot create a vector larger than max size. And so, you can make a vector, and you can make a list of ints named L of size 100. That works. So pretty common, right, to actually just fire up Godbolt and just see, because this is like we're not talking about like obscure like hacker whatever's. It's like when people are investigating performance, and performance really matters, and people are like, hey, I want to squeeze maximum performance out of things. It's very common for them to just try it out in Godbolt and just see what kind of assembly is getting generated out of it, right? It's like this is not having any optimizations on, so we'll do 03. Oops, what happened there? Caps lock on? Yeah. Dash 03. And you can just compare the difference in assembly, right? And see mimset, right? So what it's going to do here. It's going to new a chunk of memory. It is going to mimset 400 bytes of memory, probably all to be zeros or 7. Is a 0, yeah. So it's going to mimset a big chunk of RAM to be 0, because because a vector, right, calls the constructor on all the elements. Vectors don't have uninitialized variables, and so what they could have done was done a for loop where they 100 times call the default constructor on the member, which would set it to 0. But the optimizer's like, no, these are integers. It's contiguous memory, and they're all being set to 0. So you can just mimset them all to 0. And so that'll call mimset. Mimset can oftentimes blank entire chunks of RAM faster than you would do it using a for loop. So, and then we can come down here to the list and see that it is not, in fact, able to do that. So it would have to, do more work, right? And so it's very common to use Godbolt these days. It's like kind of like when people are just having discussions about which approach is better, they'll just fire up Godbolt and just look and just see what kind of assembly comes out. And so it's really important to know assembly, because then you can understand what the right-hand side of the screen is doing, and then so that's that. And then to see if a compiler has an error, right? Because there are compiler errors. Like it's possible that we found one in CSI 41 this semester, Mui and me, right? Because we were getting different outputs based on if the optimizer was turned on or off. And we were getting different outputs based on if the input tester was running or if they were running it manually, which shouldn't happen. So, there's a certain possibility that we discovered a compiler bug. And I just didn't have time to dig into it because I had surgery on Tuesday, and life was kind of miserable Monday, Tuesday, Wednesday, and today. And so I was just kind of like, nope, I'll just give everybody full points. I don't care. You've got a 6 or better, full points for everybody. I don't want to dig into this right now. I don't feel like it. So it's quite possible, though, it was a compiler error. And so if it was a compiler error, then you have to understand assembly to look at the assembly coming out of it and say, no, it should have been this, and you're doing this. It's wrong. You can file a defect report with the compiler people.
We should have tried it with Clang, huh, Muya? We could have switched compilers. And it's something I didn't think of. We could have switched it to Clang and see if the problem persisted there. Okay, so what you guys are going to do for this assignment is you're going to write a very simple compiler. So the good news is this is not a 20-week project. This is a 1-week project, kind of thing, and it's not really that bad. I've made up a new programming language called Basic, version 8, also known as BB8. And so what you're going to do is you're going to write a program in C++. It's not you're not writing this in assembly. You're going to write it in C++. And basically it's going to parse BB8 source code and generate assembly code for it. Okay. So yeah, so for this assignment, you don't have to do assembly. Well, I mean, you do, because your output's going to be assembly, right? But your input is going to be BB8, and your project is going to be written in C++. So it's not that bad. Okay, so what does BB8 look like? So first of all, if you ever read a line that does not conform to the rules below, then your compiler should just output system error, syntax error on line, whatever line you're on, 20 or 30, whatever, and then you quit. That's it. So if anything doesn't follow one of these patterns here, these are all of the commands total. That's it. There's no like what makes programming languages complicated is that they are recursively defined, right? So you can have like x is equal to x plus y parentheses times 5 parentheses divided by 3 passed into a function, passed into a function, passed into a function. No, none of that. There is exactly this many different commands in BB8, and if anything does not conform to the pattern, you immediately throw an error and quit. So that right there makes it like 100 times simpler. Okay. So yes. So every line of code starts with a number. So for example, you might have let's see. Right. So every line of code starts with a number, and that number is the line number, basically. And so rem means remark. It's a comment. So you just discard it, whatever. It's a comment. That's how BASIC works, by the way. If you guys have ever done BASIC programming, that's a comment. Line 10 says let x equal to 5. So this creates a variable named x and sets its value to 5. The only variables that exist are these, so you don't have to like keep track of what variables exist really, because it's just basically like there's only 8 there's only 8 variables allowed. All of them are single letters. All of them are 32-bit ints. Right. So all of them are initialized to 0. So let x equal to 5. If x is less than or equal to 0, then go to 100. Print x is equal to print x. X is equal to x minus 1. Go to 20, end. And so this is a for loop, right? So what this for loop is going to do, it's going to start off by initializing x to be 5. If x is less than or equal to 0, you go to line 100. Print a string. Print the value of x. Decrement the value of x. Go to line 20 and end. So, yeah. So there is a language specification in here, but basically, this may seem a little bit hard, but the good news is like all of the strings are hard coded, right? So all of these strings can be put down in the data section, because what you're going to be generating actually is an assembly file. So your code is going to take a BB8 input and generate a .s file out of it. And so how do you do that? Well, for every line number, you just turn that into a label. That's what I do. So if you want to do a go to 100, this line of code would do a branch always, or in this case, branch if less than or equal to the label for 100. go to 20 will do a branch always to the label 20. Print the string. I grab the string and I save it into the data structure down below. So let's actually run this here. Okay. BB8. Eek. Okay. Syntax error on line 3. At x equals 5, 20. If x is less than or equals 0, go to 100. Syntax error. Why is that syntax error? Then go to... Oh, you can't do comparisons with immediates. Okay. Debug my okay. So next are on line 7. 4, 5, 6, 7, go to 20. Why is that wrong? Reminds you of Ducky script. I don't know what Ducky script is. Let x equal x. Let's see, 1, 2, 3, 4, 5, 6, 7. So it doesn't like this. I think it doesn't allow immediates, right? Yeah. Okay. So. Did I change that to a 12? Assembly failed, which means your compiler screwed up. Yeah, the compiler should have detected that I had 2 different line numbers that were the same. Okay, so there we go. Compilation successful. Executing program now. It prints out x is equal to 5 and quits. Oh yeah. If x is less than z, then go to 100. I had that backwards. Huh? Alright, so x is equal to z. Equals. Double equals. How did that blow past that? Five is less than 0. Let's see here. Doing something wrong. Here, let's do a simpler one. 10 print high 20 go to 10. So the program, you guys saw that, basically prints hello world or whatever high, and then 20 goes to 10, and yeah, that's it. And so that goes into an infinite loop. And so what this code does is when you run it, this is the assembly that the compiler produced. So it starts off by initializing everything to 0. I basically, there's a reason why there's a limit of 8 variables, because each of those 8 variables is going to correspond to 1 register. So all the registers get initialized to be 0. I load the address of a string into register 0. I call a function called print string to print it. You can use helper functions, it's fine. Of course, the world doesn't want me to switch your OS. Anyone seen this before? You should be using the tool that Noobs gives you to flash it. So you can see I generated a label for line 10 called line_10 colon. This is the line that prints hello world, or hi in this case. And then for line 20, it just branches always to line 10. So what you can do is you could just go through each line of input and translate it into a line of output. So for each variable, there's one register corresponding to them, right? So X would correspond to register 4, Y, Z, A, B, C, and I. You know, so I basically just hard code one of the registers as one of the variables, so you don't have to do register allocation. Won't even read the drive. It's on a Linux file system. Fresh SD card. You might have to format it. Yeah. You might have to format the SD card. Okay. So yeah. So every time my compiler runs, it creates a new assembly file. The assembly file starts off with that basically every time. It ends with that every time. I don't know why I returned 42. It's funny. And then every time I do a print command, I just remember that string, put that string at the end of the file. And basically all you do is you just one-to-one translate a line of BASIC into a line of assembly, or a couple lines of assembly. And that's all you do. That's all the program's gonna do. If you say, for example, let's run it, 10.x equals 10, 20, print x, 30, and it prints 10, right? So if we cat main.s, you'll see the assembly that it makes for it is that it puts 10 into register 9, so register 9, I guess, is the variable x. And then when I do the print x command, it moves the value of register 9 into register 0 and calls the print number function, the helper function. Line 30 branches always to quit. So that's it. So it's just, do you guys see that? Like, it's not really that bad. It's a compiler, but it's, you're gonna have to learn, you know, to translate, I guess, this fake programming language into assembly. But when you're done with it, it's a good feeling, because this is honestly one of the more complicated things, you know, a programmer can do. And I mean, this one's a pretty easy compiler. But, so we're basically writing this in C++. You're opening a .s file and writing the commands into it. Yeah. And so for the project, why is everything executable? Chmod, everybody may not execute everything, and then make clean, and really there's no make clean. Who wrote this? Okay. Clean bb8, a.out, and start.o, and core, why not? Make clean, and make. Okay. So basically, this file here, when you run it, it's going to be echoing. It's going to be echoing a bunch of assembly commands into main.s, right? And so when you start off, you're going to create global main, and so you're writing a program that writes a program. Does that make sense to you guys? Like, you're writing a, you know, you're not writing assembly. You're writing a program that will write assembly. So you have to put all of your knowledge to use. No arrays, no classes. Just the most basic assembly out there. Keep track of what line number you're on so that you can do a syntax error, right? Syntax error on line 3, whatever. Transform, so all the input automatically gets uppercaseified for you, so you don't have to worry about casing or anything like that. If they typed in quit, it should be end, huh? Exit. Yeah, okay. And so then you parse the command. So if the command, let's see, it pulls out the line number and generates a label for it. If the command is rem, then it just ignores the rest of it, goes on. If the command is go-to, then it reads from the string stream. Like if they type go-to 50 or whatever, then it reads the number 50 in there. If an error occurred, in other words, they didn't have an integer there, then it dies and says syntax error on line 5, whatever. Otherwise, it's going to do a branch always to line 50. And, you know, you're just going to do this for each of the different commands, right? So I've got the skeleton all set up for you. When it finishes, it like the quit gets emitted for you. So you can branch always to quit. That's all working. Closes the file. And then after you've made this main.s, then it runs G++. So after the user is done inputting their program, it automatically will run G++ on main.s with the helper files linked in, the printint and print string helper functions linked in. And if it failed, then you goofed. If it did work, it says compilation successful, executing program now, and then it runs, remember the command exec. So it actually runs the program that you just made. So your program, your compiler generates a .s file, it compiles it, and if it works correctly, then it becomes it. And then the program runs hello world in an infinite loop or whatever. Okay. So this will kind of hopefully bring all of your knowledge together and help you understand everything that's going on in this wild world. So you're using the C++ to write the G++? No, you're using the C++, yeah, okay. To write a G++ equivalent that then calls the G++ on the assembly you make to make an executable, and then you become the program that you made. Here. This doesn't look too hard, I'm scared, because it doesn't look hard. I tried to make it not too hard. The only part that you need to do is just parsing each of the different commands in BB8, setting a variable, testing a variable, right? Like if it says like if x is less than y, go to 50, then you do a comparison. Compare x, which I guess in my case is register 9, with y, which might be register 10. So you do CMP R9, R10. You echo that out to the thing, and then go to line 50. Okay. Branch if less than, like if it's a less than sign, I do a branch with less than. If it's a greater than sign, I do a branch if greater than. It's 200 lines of code, everything that I have here. I made a helper thing that just translates between the variable and the register, so it's always hard coded. So every time the user types X, it just echoes register 9 instead. So pretty straightforward. I start off initializing all the registers to 0. So like here's my command for if. I'm not going to show you the rest of it, but I'll just kind of go through this. So like the user types in if x is less than y, go to 50. All right. Then it's going to parse the entire string all at once. This is using string streams, right? If you don't know string streams, let me know. We can go over string streams. But I've got a string stream. Every line is one command, so you don't have to worry about, like in C++, you can split things over different lines, right? Like you can have, like that's perfectly valid C++. Not in BB8. In BB8, every line is a standalone command. And so it just does a get line, and then you can just parse the thing. And if it doesn't parse properly, die. Right? It's as simple as that. If it didn't parse properly, die. And so it's going to, the syntax for an if statement is if variable name, comparison, variable name, go to line number. Right? And so if x is greater than y, then go to 50. And if any of those things don't match up, instantly dies. Then must always be equal to then, go to must always be equal to go to. If those don't match, die. Okay. And then we convert line to from string to integer. And if that fails, die. So if they don't type in an integer here, die. And then there's an optional else, go to something else, which you don't need to worry about. So if they typed in x here and y here, this looks up which register x is. It'll convert x to R9. So look up y and give you R10 or whatever. And then it just emits assembly code. Do you guys see that? So it's going to do a comparison between register 9 and register 10. Just echoes that to the screen. Echoes that to the file. And then if the user was like, if x is less than, it does a branch if less than. If it's less than or equal to, it does a branch if less than or equal to. It's not equal to, branch if not equal to. And then after that, yeah, that's it. That's how you do branches. Yeah. And it'll branch to a line. And so for every line that I have a label for it, right? So, because in BASIC, every line has a label. This is line 5, this is line 10, this is line 20. And so basically it'll just say branch to line 50 or whatever. And then that's it. \T is the tab character. Yeah. So that's how you do an if statement, and translating from input into assembly. And it's pretty straightforward. The only thing that you need to be careful of is the print hello world kind of thing. You have to, the data section goes down below, right? So if you do like 10 print hello world, 20 print goodbye world, 30 let x equal to 10, 40 if x is less than y, go to 10. Syntax error. There's a then in there. 40 if x is less than y, then go to 10, 50, end. Compilation is successful. Executing program now. Hello world, goodbye world. Okay. It didn't do the jump because y defaults to 0, right? So if we look at the assembly it generated for it, you'll see it starts off by initializing all the registers to 0, all the variables to 0. Print hello world just generates, like, I just keep track of how many strings I have. And so the first time I have a string, hello world, I just have to put it at the bottom. That's the only tricky bit. Is you have to. So I just made a vector of strings, and so every time I had a string that I needed to have in the program, I would just push it into a vector. And so index, the first one is string 1, the next one's string 2, the next one's string 3, and so basically I just keep track of how many strings I've seen, and so when I do a print command, I just load string and then I just append whatever index number it is to it, and I call print string, which is a helper function that you've been given. And then for goodbye world, it just loads string 2. And then after I finish all of this stuff, after I finish the quit, then I go through the vector of strings and I create a data section. So after the quit, I echo to the file .data, and then I do all of the strings at the bottom. So that's the only tricky bit in this whole thing, is you just have to hang on to the strings because you can't put it here, right? it has to be at the bottom. This puts 10 into x. This compares x and y. If x is less than y, it jumps to line 10, which it's not because y is still 0. Line 50 is quit. And so that's the only thing. So I just made a vector of strings, and every time I see a new string, or actually any string, I don't think I check for duplicates even. Every time I see a string, I just push it into the vector of strings and remember the index. And so print hello world becomes load string 1 because you're the string 1. I don't know why I don't start at 0. It's kind of weird. No, not very computer sciencey of me. So it'll load the address of string 1 and print it. Load the address of string 2 and print it. And then just at the very end, I dump the vector of strings to the data segment. And that's it. That's it. It's not too bad. There's going to be a fair bit of input parsing and things like that. So if you don't know string streams, make sure you ask. All right. Yeah. And so then your program compiles. Then the compiler executes this command here, g++ main.s print.o, and then it runs the a.out for you. Hello world, goodbye world. Okay. So that is a fun little assignment. Then readme file. Why is this not working? Is it doing this? Like, I feel like this thing isn't working properly. So it puts 0 into... See, line 5 is a comment. It still puts out the label in case you want to go to. You can always go to a comment, but... so you need the label there. Okay, so let's see if we can figure out why this isn't working. So move R9 0. So x is equal to 0, z is equal to, oh, maybe because z is a R12, and R12 isn't preserved. That might be a good reason. Let's not use z, let's use a or something. Yeah, be careful with register 12. Register 12 is a scratch register, so don't rely on register 12 to be saved between function calls. When's this due? I don't know. When do you want it due? Monday? I'll let you pick, Shami. When do you want this due? A week after the physical computing? So 2 Mondays from now? Yeah, I guess we could do that. I mean, I don't know. Basically, all the program is just taking a line of BB8 and emitting assembly for it. It's okay. All right. Sure. Yeah, it's okay. So let me copy the README file into sudo deploy homework csci45 some compiler, and then let's talk about your projects. Got 13 minutes left. So for your projects, I would like for you guys to actually propose a project to me. again, you guys kind of got screwed by the pandemic, but I do want you to have like a little bit of that project building experience. So that's why I left things kind of nebulous, right? Like for chess, I kind of maybe gave a little bit of detail on kind of what I'm looking for. I just like for a assembly-based implementation of chess. But for bridges is wide open. In fact, I'd probably accept, any bridges thing you can think of. If you're doing bridges, maybe it might be interesting to have some people access classes from inside of assembly, because I kind of talked about it, how every class has a different offset inside of it. We haven't really done anything with it. But really, any idea that you have is fine. If you want to partner with somebody, I'm fine with that too, I guess. And so, if you're a bridges person, go onto the UNCC website, get, well, not the women's service learning one or whatever, but, not that one, this one. And, if you want to do it in Python, I'm not going to stop you. Pick something that you think will expand your learning, your personal learning. Don't do something you've already done in 40 or 41. I want you to learn something, right? For data science, come up with a good data science project. We've got this thing called I2IC set up, which 2I2C, where they've given us all of these like cloud computing credits and things like that under a grant right now, and basically you can load up data into it and then use Python to do data science stuff. Motzenbacher is going to be giving a talk tomorrow on data science. You guys might want to wait till tomorrow to propose your idea to me. But try and get those to me at least over like the weekend, and work on the physical computing till Monday. The compiler, if you get the physical computing thing done, and then just have a proposal to me by Tuesday. I'll put it up on Canvas and make it worth a couple points so you guys don't forget. But like any sort of data science thing you guys can think of, there's a lot of ideas out there. Data science data sets are also a thing. These aren't the ones that I looked at before. Our data sets 538. Yeah, okay. Buzz, no. NASA, no. I've used that before, actually. Kaggle, yeah, UCI. That's what I was thinking of. So basically, data.gov. Yeah. So there's a lot of data out there, and data science makes you very employable, and so grab a big data set, do some sort of analysis on it. Okay. You can use your own data, sure. You said the bridges option is capped, right? Let me see how many people we got in it. How many windows do I have open anyway? Yeah, so the data science thing, like I said, we have computing credits and you can run your code on here. I'd like to use it because otherwise I will be embarrassed in front of my colleagues at Berkeley. Project categories, responses. What do we got here? Raspberry Pi, bridges, chess, data science is capped, yeah. Oh, Opencv is the other one, right? So the chess people, yeah, the two of you can work together. Alan and Shami, you guys can work together on that if you'd like, or not. Be antisocial. It's up to you. But it'd be nice to have some sort of operating chess game written mostly in assembly with helper functions in C++. In fact, if you want to do a helper function to do the 2D array accesses, go for it. It's fine. I just want to see most of it in assembly. Raspberry Pi people propose a physical computing project. You want to work as a partner, work individually, I don't care. Just propose something, it's like what we're doing right now. Bigger, though, I guess. If you have Tinkercad, I don't know how that would work. You might want to pick another one. So yeah, the bridges people go through the bridges documentation, find a data structure, something you've never used before, or a language you've never used before, something, anything. I don't really care. Like I said, this is a pretty open final project. Opencv people, there's only 2. That's a little disappointing. If there's anybody who hasn't signed up for something, I'd recommend doing Opencv. Because we do Opencv every year in this class.
Excuse me!
Yeah? What happened? What's wrong?
You closed Opencv because too many people were signing up for it.
Well, only 2 people are on the thing.
Well, then I'll take it.
All right. Well, you know, I don't know. You tell me. Like, there's two people here on the Google Forms. I thought there were more, but
You know what? Shammy, Walker, Ribera, and I, we're all doing Opencv. We're all one group. We're doing it.
yeah. Well, so Alan's getting tossed to the wolves, huh? No, Shammy signed up for chess. So, oh no, there's 3 people on chess now.
Shammy wanted to do Opencv.
I see.
Like Shammy, Ribera, Walker, and I all wanted to do Opencv. But
Okay.
about it.
What are you guys signed up for right now?
I think we're all in different stuff.
Okay, then that should be fine. You tell me. Like, is like on the chat channel there was like a lot of people signing up for Opencv, and now there's 2. So.
Yeah, I mean,
it looks like there's room. I just don't want everybody doing one thing. You know what I mean? But,
yeah, that's understandable. We're all kind of in different stuff, so it wouldn't be taking too much from one place.
Who just question? Let's see, individual responses.
Should we resubmit or something, or?
No, it's fine. I can handle this. If there's 3 people in chess. So who signed up for chess with Alan then? Okay, so Opencv. Let's get through this before the end of class. It looks like you all good partnering in Opencv. You're just Muya is just like executive, like forming a group. You know, data science. Okay, yeah. Chess is really what needs more people, but it's fine. Okay, so Opencv is I do this every year with my students, and I do not accept your cookies. I don't know why you need my cookies. And hire a team of experts. Now I guess that's how they make their money. So Opencv has a lot of really cool stuff it does. Let's see. Tutorials here, and you can see like face analytics pipeline, pictures, text. Yeah, so they have classifiers, and so it can try and classify somebody based on their age, their gender, that kind of stuff. Again, pretty open-ended. I think I said in my video on Tuesday, I had students who did Opencv to do car counting and things like that for the Fresno Department of Education. Image recognition is like one of the, obvious uses of it. But there's a lot of things in here. So what I would do for you guys is just go through the list of tutorials and find something that kind of resonates with you, and then just start from there. All right, you don't. This final project is not designed to be something lethal. It's just designed to be something to expand all of your consciousness, like the spice. Okay, you understand, will you? So go through the list of tutorials, find something that's kind of along the lines of what you want to do, and mod it. Okay, and that goes for everybody. Okay. Find something that looks cool to you, that you'll learn something, that'll make a cool little project. Again, it's not supposed to be lethal, just interesting. Don't be like, I'm going to print out Hello World and Bridges now. Better than that, and students oftentimes underestimate how much work things can take. So, don't. just see if you can get something, see if you can get the tutorial working. If you can get the tutorial working, you're already like halfway there, you know what I mean? If you don't have a working Raspberry Pi, I would probably shy away from doing a Raspberry Pi project, maybe. I'm going to print out Hello World now. I'm not going to allow something that low brow to go through, but This class is famous really for shooting chancellors. Wait, no, for our projects, right? And so this will be like your one opportunity to kind of do something cool and contribute to the legacy and reputation of Seaside 45 here. So, it asks how many elements you want to add. I'll insert that many elements into a tree. That's probably a little too simple for the bridges assignment. Like it's visualizing a tree. Like, more than that. Do something interesting with it. I don't want to just detect demo. I want something interesting. Right? So use bridges to visualize something. Right? Because that's what bridges is for. Bridges is there to visualize data structures. And so, if you're making a supermarket app, then use bridges to visualize your inventory or something like that. Okay. How do we access the Berkeley Data Science Jupyter portal? I will need the names. I will need the email addresses of everybody who's doing data science. Thank you for reminding me. And I will, I go to the admin page here. Data science people. I will go to the admin page. The admin page. DoorDash, that's not it. I'll go to the admin page. There we go. And I click add users. And so I'm going to need your usernames, basically. So your email addresses. So I'm going to need the email address. Just message me. If you're doing data science, message me your email address, and then I will add you to the thing here. Okay. And then you can upload data into it and start doing data analysis on it. Okay. I severely overestimated how much I'd want to do our 50B assignment. You've lost interest in 50B. That's unfortunate. All right. So aiming for simplicity. That's fine. But just make it be interesting. You can do simple and interesting. Okay. So I'll make a note. Everyone doing data science. Everyone doing data science. Message me your email address. I'll get you all set up. That's it for today, guys. Okay. And as always, you guys have access to this notebook, right? Like this thing here. Share. You guys have access to this, right? It's like pinned or something. No, maybe not. Okay. Anyone with the link? View, copy link. Okay. One note. How did that not copy? There we go. Yeah, it's been a fun semester. So next week should be pretty chill. I don't have any new material to teach you guys, so it'll probably be us just hanging out and talking about projects next week and the homework assignment. Because normally these projects sort of get interleaved through the semester. We didn't do it, so we just, have a couple extra weeks at the end. So I'm happy you guys are going to be able to do a project. So, is there a final exam? Yeah, it'll be the same as the midterms. A little bit of hex and a little bit of assembly and stuff like that. The usual. Probably the topics are going to be pretty similar to midterm 2 because, the only thing we've learned since then is this kind of stuff, and I guess I could put some of this stuff on it as well. When's your final? It's in 2 weeks or something like that, right? Next week is week 18. The week after that is finals week. Am I right in remembering that right? Students usually know better than professors, so I'll just keep talking forever. Like you can't stop me. Yeah, Thursday finals week. No, it won't be Thursday finals week. I'm just gonna open up. I'll open up the final for the whole week. You can just take it whenever you want. Okay. So once you start it, you'll have 2 hours to finish it, and there'll probably be a little bit of coding on the server again, but yeah. Okay. So yeah, technically, I think it's supposed to be Thursday finals week, but I don't care. I'll just open up the window. it's an asynchronous class. You can take it whenever suits you. Okay. So that is it for today, guys. Thanks a lot, and I'll catch you on the flip side. See ya. Have a good weekend.